Hello, welcome to this video 6-2, and we are going to find sine, cosine, and tangent values of acute angles in a right triangle. So, without further ado, that's what we are doing today. You will be successful if you can label the hypotenuse and the sides that are opposite and adjacent from a given angle that we're trying to find trig values for. You will be successful if you know the sine, cosine, and tangent ratio definitions, and you can simplify a ratio when necessary. So, just some prior knowledge that we want to go ahead and cover really quickly is this idea of rationalization of a fraction. If your denominator has a square root in it, we rationalize this, and I make my denominator a rational value instead of an irrational value by multiplying top and bottom by this square root of 6. And you're just going to multiply by that same exact value, whatever that denominator is. And what we get in the numerator is nothing too crazy. We get 5 square root of 6. But in our denominator, I have the square root of 6 times the square root of 6. And this is going to equal the square root of 36, or 6 squared. And hopefully you notice that when I do this, square root of 36, that is a perfect square. So square root of 36 is 6. And so notice through this process of rationalization, we actually make the denominator a whole number, okay? So I want you to go ahead, pause, and I want you to try this example here, and then I'll show you the rationalization of 4 over root 7. All right, hopefully you went ahead and multiplied top and bottom by square root of 7. And when you do this, what you get is 4 square root of 7 over the square root of 49, which is 4 root 7 over 7. Okay, so that is rationalization, and that should have been review. All right, let's go ahead and let's talk about labeling. When we are going to, find trigonometric ratios of an acute angle and a right triangle, we have to be able to label the sides of the triangle. And we kind of did this in the last video. We always found the hypotenuse, which was the side across from the right angle, and it's always the longest one. But we're going to be given an angle in order to solve or find values for. Well, the side opposite is going to be the side opposite of the given angle, or what we're trying to find a trig value for, okay? And that makes sense. The side opposite is the side opposite. Now, the other side, and that's kind of why these are arranged in this order, the other side, the side that is next to that angle, is called the side adjacent. And that's the side next to it that is not the hypotenuse, okay? And so we have 3 sides: the hypotenuse, the opposite side, and the adjacent side. So let's go ahead and look at this first example here. We are using angle A. This is our given angle. And so it's important to notice that the side that's hypotenuse is always going to be this line segment AB. Always, 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 always. Now the side that is opposite of A, if I look directly across, that's going to be the side opposite, okay? And it's almost like if angle A had arms and it was reaching out, the side that would connect its fingertips, that's the side opposite. And then the side that's next to it, that's not the hypotenuse, that's the side adjacent. Okay, now it's very important to note that the hypotenuse will always be the hypotenuse, and that the opposite and adjacent sides can switch depending upon what angle you're in. So notice now, what if I cared about angle B and not angle A? Well, now if I'm angle B, the side opposite is this line segment, AC, and the adjacent side is BC. Okay, so you see how that switched? Very important to know what angle you are using. So we're going to go ahead and we're going to practice labeling. They say use angle D, label the sides of the right triangle. So, okay, what I like to do is I like to circle or just make note of what angle we're using. So here's angle D. Then hypotenuse, always going to be directly across. So here is the hypotenuse. And then if I'm in angle D, directly across from angle D is the side opposite. So here, line segment EF is opposite. OPP is how I label that. And then the side right next to it is adjacent. And so I I label that ADJ for adjacent. Okay, so hypotenuse, side across from D is the opposite, and the side next to it is adjacent. Okay, what if our triangle's oriented this direction? So now here's my angle, angle D, and the side that's hypotenuse is the longest side across from our right angle. So there's hypotenuse. And then I want to go ahead and again, I'm going to label. So directly across from D is this side. This is opposite. And then this side will be adjacent. Fairly simple. Fairly simple. Okay. I guess we got some practice problems here. Go ahead, please pause video. Using angle R, go ahead and label these sides. I'll show you the results here in a second. Okay, hopefully you went ahead and labeled. If we're using angle R, here is R. SR is your hypotenuse. TS will be your opposite side, and then TR is your adjacent side. Okay, not too bad, so hopefully you got that. All right, let's look at next one. Here is angle R. The side that is the hypotenuse is directly across from your right angle, and then the side that is opposite R is going to be opposite, and the side that's next to it, that's not the hypotenuse, is adjacent. All right, hopefully you did good. Okay, one more set of example. Please pause me and try these. Okay, if we're using angle Z, here's Z. This side will be hypotenuse, this side will be opposite, and this side is adjacent. Okay, hopefully you did good there. And then lastly, here's angle Z. This is going to be our hypotenuse. Here's the side that's opposite, and here's the side that's adjacent. All right, let's go ahead and talk about trigonometric ratios. A trigonometric ratio is a ratio of two sides of the right triangle. The three primary trigonometric ratios are sine, cosine, and tangent. And now sine, cosine, and tangent have abbreviations which are commonly referenced. We have SIN, that's sine, COS, that's cosine, and TAN, that is tangent. And you can find these trigonometric functions on calculators. If you see these are the trigonometric ratios. Now it's important to understand that what we plug into our trigonometric functions, the input, are angles. So sine of A here, this is the angle. So whatever this angle could be, and it could be, I don't know, 30 degrees, could be measured in radians, could be pi 6 radians, but that's an angle value that we plug in, and it will be equal to the ratio of two sides of the triangle. Now, what two sides do we use? Well, that's where we have our good old mnemonic device called SOHCAHTOA. SOHCAHTOA is how we remember the side ratios of a trigonometric function. So, SOHCAHTOA. And I really like the acronym represented in this manner. So, where I place the first letter is your trigonometric function. The O is the side opposite, and then hypotenuse is on the bottom. So it's opposite over hypotenuse. Cosine, so adjacent is in your numerator, adjacent over hypotenuse. And also too, there's some patterns here, sine and cosine. Hypotenuse is always in the denominator. And then we have our last trigonometric function, SOHCAHTOA. It's opposite over adjacent. Another way to think about it is that opposite is always on top for sine and tangent. SOHCAHTOA. Some people says it sounds like suck a toe. I don't really hear that. Okay, but if you know that's your thing, sucking on toes, then be my guest. You can remember SOHCAHTOA that way. Okay, so SOHCAHTOA. Let's go ahead and generate some trig ratios, and then they say simplify if possible. Example 1. We want to find sine of angle A, sine of angle cosine of angle A and tangent of angle A. So again, the first thing that I like to do is I like to label. Now it's very important you understand that we are using angle A. Angle A is what we're using. So then our hypotenuse is going to be 10. The side opposite is going to be 6. And the side adjacent is going to be 8. All right. So Katoa, man, I already forgot it. If that's the case, write it like this. So Katoa. It takes 2 seconds to write down again. So that way you don't even have to flip back in your notes. So Katoa. So sine is opposite over hypotenuse. Okay, well, what's my opposite side? Well, 6 is the value of my opposite side over my hypotenuse, which is 10. Now this does reduce. 6 over 10 does give us 3/5. Okay, next. Cosine of angle A. Well, cosine is adjacent. The side adjacent is 8. So I have 8 over 10, which gives us 4/5. And then we have tangent, which is opposite over adjacent. So the side opposite, that's 6. Divided by the side adjacent, that's 8. We get 6/8, which reduces to 3/4. Okay, not too bad. You're just writing your trig ratio. Okay. All right, let's make it a little bit more complicated. Let's throw in a square root, because why not? Sine of D. All right, where is angle D? It is right here. So the first thing, again, I'm going to do, I'm going to label this is hypotenuse, that's 7. The side opposite is the side directly across from angle D. So if you're in angle D and you go directly across, side 4 is your opposite side. And then here we have the adjacent side is square root of 33. Okay, so SOHCAHTOA. Well, I want opposite over hypotenuse. 4 over 7. Cosine of D. Well, I want adjacent square root of 33 over hypotenuse. That's 7. And then we have tangent of D. Tangent is opposite. Okay, so this is 4 over adjacent, which in this case is square root of 33. Now that's the correct answer, but we do want to go ahead and rationalize here. I'm going to multiply both sides by the square root of 33, square root of 33, and what we get is 4 times the square root of 33 divided by the square root of 33 times the square root of 33 is equal to the square root of 33 squared, square root of 33 squared, which just cancels, and so we just end up getting 33, if you didn't pick up on that in the last lesson. Okay. Here are 2 practice problems. Please pause the video. I want you guys to fill in these trig ratios. Go for it. Okay. Example 1, they want angle X. So 13 was your hypotenuse. 5 is the side opposite. 12 is the side adjacent. And so please check your work here. For sine, opposite over hypotenuse, that's 5 over 13. For cosine, that is adjacent over hypotenuse, so that is 12 over 13. And then tangent, this is going to be opposite, which is 5 over adjacent, which is 12. Okay? Rock on. All right, next example. Please pause me if you have not done this example. Okay, angle N. So here's N. 2 is the hypotenuse. 1 is going to be your opposite side, and then square root of 3 is your adjacent side. So here we get opposite. That's 1 over the hypotenuse, which is 2. For cosine, that's going to be adjacent over hypotenuse. So in this case, square root of 3 over 2. And then tangent is going to be opposite over adjacent. So this is 1 over square root of 3. And hopefully you rationalize this. Did you multiply by square root of 3 over the square root of 3? Which gives you root 3 over 3. Okay. Awesome. Hopefully you're doing well. Hang in there, we're almost done. I have one more example and then one more practice problem for you, of course. So we're going to go ahead, we're going to find sine, cosine, and tangent values of this trig function. And again, our steps are not going to change. I'm working with angle F, so we must label the hypotenuse, the side opposite, and the side adjacent. And then we're going to go ahead and find these values. So sine is going to be opposite over hypotenuse. Our opposite side is 6 divided by our hypotenuse, which in this case is 2 square root of 10. Now notice they're both multiples of 2. So I'm going to reduce by 2. So I get 3 over the square root of 10. And now I want to go ahead and I want to multiply by the square root of 10 in order to rationalize this. So our answer, 3 square root of 10 over 10. Okay? Now, again, if you're wondering what happened here from step 1 to step 2, all I did from step 1 to step 2 was I reduced. I reduced by a factor of 3. And then from step 2 to step 3, I went ahead and I rationalized this, rationalized that. Okay? All right, next, cosine. That's adjacent over hypotenuse. So 2 over 2 square root of 10. And when we reduce here by 2, the 2's cancel and you get 1 over square root of 10. So we'll multiply both top and bottom by square root of 10. And we get square root of 10 over 10. Okay, last one, tangent, opposite over adjacent. Usually this one is the most difficult. Opposite is 6, adjacent is 2. And 6 over 2? 3. Okay? All right, so that's going to do it for examples. Here's the last practice problem. Please try this. Double check, make sure you got the ratios, and then reduce if need be. Okay, hopefully you went ahead and labeled. Here's M, so 3 root 5 is your hypotenuse, 6 is the opposite side, and 3 was the adjacent side. So opposite over hypotenuse, that's 6 over 3 root 5. And if you reduce here by 3, you get 2 over square root of 5, which when we rationalize, when you multiply by square root of 5, top and bottom, you get 2 root 5 over 5. Okay, next, cosine, that's adjacent. Your adjacent side is 3, and your denominator is 3 root 5, that's the hypotenuse. So we can reduce here, we get 1 over square root of 5, because the 3's reduce. We'll multiply both sides, top and bottom, by 5, square root of 5, and you get square root of 5 over 5. And last, tangent of M. This is going to be opposite over adjacent. So again, opposite is 6 over 3, which is 2. Okay, in this video, we went ahead and we talked about how to find trigonometric ratios, sine, cosine, and tangent values of acute angles in a right triangle. Hopefully you were able to do that, and that you were able to label those sides appropriately and then simplify the ratio when necessary. I'll catch you in the next video. See you later.